Hello, what's up? Gleb Alexandrov here for CreativeShrimp.com. In this photogrammetry tutorial, we'll try to make it a bit different to what we usually do. We'll take this car, an average smartphone, no DSLRs, mirrorless cameras, nothing of that sort, just a smartphone, a bunch of photos. Then we'll run it through the entire pipeline of photogrammetry, starting with reality capture and then polishing it up in Blender, so on and so forth, just to show how to make it usable, because by default the asset will end up horrible.
And we don't want it to be horrible, right? A melted and fluffy geometry that looks like a hellish marshmallow, the exploded mesh full of noise that has to be cured somehow. The good news is that it doesn't have to be like that, it can be like that instead. A pretty clean photo scan with a crispy texture enhanced by a neural network, ready to be used as a background or even mid-ground asset in your game or 3D scene. Now that sounds and looks a lot better, right? If that sounds exciting to you, it probably should. And we start in 3, 2, 1. As for the scanning session, it was the laziest part of the workflow. I just captured this truck on my way back from coffee shop. We will talk about the camera settings, or rather smartphone settings, a bit later on. Let's just mention that it took approximately 100 photos to encapsulate this object, to fully capture it from all sides. Well, I didn't crawl underneath the truck and didn't jump with smartphone to capture the roof, but aside from that, I tried to complete the angles required to fully photoscan this object. So on to pre-processing the raw photos taken on my smartphone, OnePlus 6T Pro to be exact. We have here the RAW folder and the folder with JPEGs. And even though the JPEGs could be technically usable for photogrammetry, some things about them are not as good as with RAWs. The one that is evident right off the start is the dynamic range. You can see the pure white highlights that were clipped by the smartphone processing slapped on top of the image, and the overall contrast ratios and just slightly oversaturated colors is something that strikes as wrong. We talked about it in more detail in the color management chapter of the course. So let's have a look at our RAWs for comparison. Here we have a bunch of DNG or digital negative files, which are the RAW sources. And what I'm going to do is fire up Darktable, which is free and open source software for editing RAWs. And I will drag all these DNG files in there. Here they are. We can check the metadata of the images in the Image Information tab. Here we can check once more the model of the smartphone, which was OnePlus 6T Pro, aperture, exposure, and most importantly, resolution. It's 4K by 3K, haven't been scaled yet, naturally. These are the RAW images, what I'm even talking about. So I'm gonna double click on any of them to enter the darkroom mode, where we develop our RAW photos. And right away, it's evident that the RAW files hold more dynamic range that we can work with. By the contrast to JPEGs, it may look a little bit washed out and flat, but that's how it should look. Oh, and by the way, we can jump between Lighttable, where we see all our RAWs, and Darkroom, where we process them. Now I'm gonna click on the hamburger icon and select all modules. I'm gonna show the base curves in the base tab here, so it's important to get access to all these tabs and modules. The problem with the base curve module is that if you see anything except the line here, the straight line I mean, for example, if you see the Samsung like this S curve or anything else of that sort, it means that some aesthetic transformation has been applied already, so we need to reset it to get back to the scene levels of contrast. Or better yet, let's disable the base curves at all. Let's keep it linear. Now back in the hamburger menu, I'm enabling the scene referred selection of modules to get just the things we need for the scene referred adjustment. Along the same lines, we don't need the curve in the Filmic RGB tab as well, so I will just disable the Filmic RGB. And even though it made everything look like it's clipping again, we will fix it in just a moment. But before doing that, let's fix the white balance. The cool thing about RAWs is that we can adjust such things as the temperature and, to some extent, the exposure after the fact. So we can click on the eyedropper, find the patch in the image that is close to gray, to the neutral gray, and just outline it like this. By doing it, we help Darktable to define the scene illuminant temperature. The correct white balance, in other words. At this point, we can adjust the exposure as well, but that's something that I will do just a little bit later. First, I think we can do some kind of a fake delighting or toning down the overexposed parts. In the Tone Equalizer module, we can adjust the individual bands, like 0 exposure value, -1, -2, or we can hover over certain area in the image and use the mouse wheel to adjust them like this. So I'm toning down the highlights so they fit into the visible range and pushing up the shadows. The effect should be a little bit similar to shadow highlights adjustments or to delighting the image in something like Edgesoft Delighter later on. Of course, it's not as smart as real delighting powered by artificial intelligence and that sort of stuff, but it gets the job done by squeezing the dynamic range, even though it's a little bit of a fake. Then what I'm going to do next is switch the exposure mode to automatic and adjust the target level so we see no overexposed parts and underexposed parts for that matter. The automatic mode will be helpful for matching the exposure levels across all the images. Okay, I'm checking that there are no modules enabled in the rest of the tabs to the right, and it looks almost good to me. The last thing I'll check is the highlight reconstruction module. In case you don't see this module, make sure to enable all modules within the hamburger menu, then it should appear. Okay, so the highlight reconstruction. It's set to clip, how disappointing. Let's set it to reconstruct color instead, because clip, well, clips everything. It would be extremely disappointing to see the highlights still clip after all the efforts we put into developing the photos, so reconstruct color would work best in this scenario. It's the secret sauce that helps squeeze in most of the visual data present in the raw files into the 8-bit sRGB images. Okay, now I'm gonna click on the image that we have processed, selectively copy all the modules including white balance. Click OK, then select the rest of the rows. You can press Ctrl A or just hold Shift and click, and then selectively paste everything on top of it. Alright, again, don't worry if everything looks a little bit flat and brownish, because by adjusting the white balance to the correct value, we often make things look brown by taking out the influence of the sky. Alright, in the Export tab, I'm sticking to the 8-bit TIFF as a format, an uncompressed, nice sRGB format. Now I'm typing in 2000 in the set size field. That will effectively limit the resolution of the export to 2K pixels wide images. And the trick is that the source footage produced on an average smartphone isn't the best in terms of spatial fidelity. It isn't pixel perfect, so by halving the amount of pixel, we barely diminish the actual quality of pixels, if that makes sense. What is diminished is the processing time and the price in reality capture. So that's good to know. I'm selecting the folder for the export. Okay. And just let it run. Darktable can be a little bit slow when it comes to exporting out the images, so keep it in mind. So to sum it up, what we have just done is taken the raw photos captured on an average smartphone and we put it into Darktable to develop them. We adjusted white balance, exposure and some other important things and exported it out as 8-bit sRGB TIFFs. Oh, and by the way, here's a quick rundown of the source footage settings. 108 photos in total, taken on OnePlus 60 Pro smartphone in the RAW mode, with the f-stop being 1.6, ISO 250, exposure time 1/100th of a second, focal length 5mm with a sensor size, the one that you see on screen right now. With the source photos developed, we should have no problem with reconstructing the 3D model in Reality Capture. I will select all the TIFF files that we have just exported out of Darktable and put it into this tab of Reality Capture. In the top right corner of the user interface, we can see that RC has kindly estimated the price it would take to license all the inputs. And by looking at the input settings or the metadata once again, we can tell that the resolution in fact is limited to 2K pixels wide indeed. Everything goes as planned. So I will close this tab and go into the alignment tab instead. Before hitting the alignment button, let's check the settings. I will switch the image overlap from medium to low, just as a precaution, I guess, and the image downscale factor should be set to 1, that's important. In reality capture's terms, 1 means divided by 1, or the original resolution, or no downscale whatsoever. After clicking the align images and waiting for a while, we should see the point cloud generated. And after that, what I usually do is clear up the reconstruction region in the Mesh Model tab to just see it better. And then one more thing that will make our life way easier when we have to clean up the model in Blender is to go to the Tools menu, to the ground plane, click it, you will see the gizmo, and then we can adjust this gizmo in the top, front, right orthographic perspectives, because it's way easier to do it in this way. And by adjusting the gizmo, we can line up the model with a grid. That will make all the geometrical operations in Blender way easier in terms of selecting stuff with the rectangular selection, for example. So it's worth doing, I think. Now the front view. I'm just trying to place the car squarely on the grid, on the ground plane that we kind of set here. And now back into the perspective mode, I think we lined it up pretty nicely. Within the Tools menu, I'm going to click on the ground plane again to deselect it, and then click on the Set Reconstruction Region. Otherwise, everything not constrained to a certain region will get reconstructed, unsurprisingly, including birds, trees, neighbors that are static enough, that kind of stuff. So, to prevent it, let's click on the Reconstruction Region, and then adjust the bounding box to encompass only what we want to see reconstructed. The car, in other words. Be careful not to constrain it too much though, because it will start to clip certain parts of the model, which also leads to potential frustration, so be careful. Be considerate with the reconstruction region. Then in the Mesh Model tab, the reconstruction settings, let's make sure that the image downscale is also set to 1, meaning that we should use the original resolution, which is 2K pixels wide for this downscale set of images, and then click on Reconstruct Normal Detail. We should be ready that it won't look spectacular right away in this set of conditions. Anyway, let's move on and fix it a bit later on. But first I will disable the visibility of the cameras within the View menu, because that's driving me crazy, I guess. And now we can give our cursed mesh an inspection. It's a fairly broken piece of geometry indeed, with lots of noise throughout, some kind of a mess instead of glossy parts. That is to be expected. The first thing that comes to mind that would help to reduce the overall noisiness is the smoothing tool in Reality Capture. I wouldn't necessarily recommend to do it, but let us check how it works. I will leave the smoothing type to noise removal, every other setting at its default value, and then I'll just click smooth. And what will happen, unsurprisingly, is that Reality Capture will apply a few iterations of smoothing on top of our original very noisy and messy mesh, and it looks probably cleaner and smoother, but I don't think it looks good. It is just more medium frequency noise instead of high frequency. It looks a little bit weird, and it has a certain blobbiness to it, which I don't like, so I think I will delete this second model and just work with this one. Consider giving it a name. car_HP for high poly, so we can distinguish the low poly and the high poly models. And the next thing on our list is to colorize it. You guessed it, the downscale of coloring and texturing both set to 1 to use the highest available resolution, then hit colorize. It will generate vertex colors for pretty much for every vertex here. It's not a texture, but it works just like a texture if the model is dense enough. Which is probably true in this case. 6 million polygons is quite enough for this background or midground model. Now we need to simplify the high poly model to generate a kind of a proxy one, which we'll use for adjusting the geometry. I said that triangle count a bit earlier, so let's use 45,000 in this case, and just hit simplify. Trust me, it will work pretty well. I have tested it already. And whoa, now there's not nearly enough vertices to hold up. So it seems that we need a good old texture and UV map. I'm gonna unwrap the model first. Let's close all the unnecessary tabs, unpack the unwrap parameters, Set the maximal texture resolution to 4K. Now, as for the large triangle removal threshold, by default it's set to 10. We need to crank it up all the way to 100 to make sure that every polygon is unwrapped. Otherwise, the bigger polygons will get excluded from the UV map. Okay, and now I'll generate the checkerboard texture just to gauge the texel density. But mainly because I love checker textures. And then a quick checkup of the texture settings. Everything looks right. We can press the texture button. This step, I believe, still requires an NVIDIA GPU with the CUDA 2.0 compatibility at least. So if it doesn't work, chances are you don't have the GPU or the GPU drivers that support it. But hopefully it worked. I will rename this to car_proxy, as it will be our proxy mesh for generating low poly mesh in Blender later on, if that makes sense. Before hitting the export button, I'll check the polygons by clicking on the solid shading mode within the view menu and back to Suite to check the texture. Oh, it is broken, but in a kind of an interesting way. I think we'll be able to fix it. Now I'll save often. And I think we're ready to export everything out to Blender. Cool. In the workflow tab, hit export. I'm gonna search for FBX from the search tab. And here it is. For each model, I will have a special folder created. 0.1_high poly for the high poly version, and conversely, the low poly for the low poly, so on and so forth. On exporting our creation, RC will ask us to license it, meaning that it wants us to license the source photos, the inputs that we used to generate the photo scan, and then we can export it out as many times as we like. For example, in the case of this photo scan, we buy our input license for $0.2, and then we can make changes to the photo scan, tweak the settings, and re-export as many times as we would like. 10, 20 or million times, as long as we don't change the source footage. And you can find the video on the explanation of the PPI or pay per input model of reality capture on our channel. The main point being that it can be pretty much not super expensive if you know how to adjust the source photos. Feel free to find this video on Creative Shrimp YouTube channel. Let's not go into the weeds right now. Save mesh by parts. No, thank you so much. Export vertex colors, yes, and click OK. Just as a quick reminder, we are exporting the high poly version of the model, the one which is noisy. Marked with an HP suffix, in other words. Now let's click on the car proxy and export it out as well. Again, click export, select FBX. It should go into a distinct folder like 0.2 proxy. And click save after all these troubles. The default settings are pretty good. The texture side doesn't matter a lot in this case, it will be used merely as a reference for modeling, so let's go 4K or 2K, that doesn't matter much here. And I think if we didn't forget anything, we should be good to go. We should be good to start mesh doctoring and cleaning up process in Blender. So we've got a pretty grainy mesh in RC, and we have to do a considerable cleanup in Blender. Let's load it by going import. Choose the FBX format, that's what we used for exporting out from RC. First I'm going to bring the high poly model in. It could take some time, it's pretty heavy. Here we go, here it is, our noisy beauty. If we did everything right, it should have the vertex colors available. We can check it out from the viewport settings menu, and it's there indeed. I will switch it over to material preview mode though for consistency, because we're gonna be previewing the low poly version in this mode, so let's set up the high poly version material as well. Basically, all we need to do is click by color in the material settings and choose vertex color in there. No need to define the specific vertex color channel, because I believe there's only one by default. Alright, so for organizing it a bit, I will create two collections in the scene outliner. The first one high poly or HP, and the second one proxy. Let's click on it to make it an active collection and disable the visibility for the HP one for the moment, and go File, Import, choose FBX once more, and bring the car proxy model in. Usually the material is created and textures are assigned automatically. Just make sure you're in the material preview mode. Here it is, the base color texture, which is car_proxy, whatever, .tiff. If there is no texture visible in this menu, it's probably because we haven't exported one from RC. We should probably do it again. It's completely fine to forget things. I do it all the time, especially when it comes to import-export. An important note before cleaning it up: if you want to bring this mesh back to RC at some point, it's not recommended to rotate, scale, or change the position of it. We can change things in the edit mode though. Alright, so our plan is something like that. We will start at the bottom and move up gradually. First we'll deal with the ground, then with the scum underneath our truck that has to be wiped out, and then we'll gradually move on to the truck body, starting probably with the wheels, and then to this part, windows obviously, because windows are the most problematic part of this mesh. As these parts were transparent and highly glossy, obviously they exploded during reconstruction, and we have to rebuild them from scratch, as well as this awful section at the roof. In brief, that's our plan, and we will try to stick to it. The question you may have is, why don't we simply start with going into edit mode, selecting some vertices or faces, and deleting them? Well, we can try. C for the brush selection, brush over these polygons. For example, we want to delete the ground, let's say. Then X and delete those faces. And then move on to these polygons, X to delete. But then we'll have to deal with kind of the messy remnants of the topology, especially in the intersections, in the places where two surfaces collide together. Like, for example, what if we wanted to select the polygons that run along this seam? The topology of this mesh in its current state doesn't allow us to do that, simply speaking. So we will have to rearrange the vertices and edges and faces before doing it like this. And that means retopology, a fairly complicated process. What if we try a different option that is slightly faster and, let's say, quick and dirty? How about that? Let's try the Boolean modeling tools to clean it up. So I will start off by creating the cube object. I'm gonna G to grab and move it down like this, then S to scale, Shift Z to constrain it to X and Y axes. And finally, we can push it down and submerge it into the ground so it covers the tarmac but doesn't touch the van itself, or just barely touches. I will rotate it so it encompasses the ground plane like this. And then we can no longer see the ground mostly. I will add the Boolean modifier just to demonstrate the concept. It's set to difference mode, so we have to pick the object that will create this difference. And to be able to see what we are doing, we need to go into the object mode, viewport display, and find the bounds mode in there in the display as options. And now we can see what the Boolean modifier is doing. But I'll switch it back to textured mode and remove the modifier for the moment, and we'll show the faster way of adding booleans. So down in the Blender preferences, we need to find the add-ons tab. Here it is. And then type in bool, and hopefully that will find you the bool tool add-on. We just need to make sure that there is a checkbox near the title. It means that it's activated. And here you can change the shortcuts for the Boolean operations if you don't have the numpad. But by default, the shortcuts are assigned to the numpad keys. So what you need to do is select the cube, then shift-click on the car and go Ctrl- on the numpad. And what it does, it sets up the Boolean modifier, automatically picks the object, and sets this object, or operand in other words, into the bounds mode, and that's the whole Boolean business. Now we can move the subtraction object, and don't mind the glitches, because no matter how you tune in the Boolean modifier, it still can be glitchy at some positions, so just move the object if that's the case. What I usually do next is apply the modifier right away after setting up the operation, and then probably cleaning up the mess. Here the C shortcut and the brush selection may come in handy, and the X-ray visibility as well. Without the X-ray visibility activated, we won't be selecting the back faces, so that means double selecting things will be needed. So just know that there is such thing as the X-ray selection that can be brought up by pressing the Alt-X shortcut, or by clicking on this icon. And C for brush selection, just as a quick reminder. Then X, delete those vertices. C again, select things, delete things, As for the Boolean operations, they shouldn't cover the entire thing that you want to see deleted in one go. It's completely fine to work in an iterative manner. For example, here I'm creating the second cube, the second Boolean object, then shift-click on the car, Control- for the subtraction operation, pressing G to grab or to move the object. Before we have the Boolean modifier applied, we can change the operand shape. Like, for example, here I'm selecting the polygon, GG to slide it, then C to go outside the bounds like this, and extend it a little bit so it wipes out the remaining trash. And when satisfied with the result, we can press this little triangle and select Apply. That will collapse the modifier, remove it from the stack, and give us the full access to all the polygons of the mesh modified by the booleans. I'm gonna delete these temporary boolean objects and then clean up the garbage left after modifier. Something like that. Maybe these little pieces as well. X, delete vertices. Now moving on to the other side of the mesh, we still have this ugly connecting tissue that has to be cleaned up at the front portion of the mesh as well. And I think we can deal with it once again with the Boolean modifier. Let's start off by creating the cube from the Shift-A menu. I'm going to scale it up so it fits the space in between the wheels like this. Then Shift-click on the van, Control- for the Boolean operation, and something went wrong. When the stuff like this happens, we can try switching the solver to fast. Oftentimes it fixes the issue. Other things worth checking out is the self-intersection option and the hole tolerant option in the solver options menu. But 9 times out of 10, changing the solver to fast fixes the issue. I think I will extend this face of the cutter object with the help of the GG shortcut to slide it and C to slide it outside its bounding box. And I will extend it to cover this space underneath the van. Something like that. I think we are ready to apply this particular Boolean modifier. And we no longer need the temporary Boolean object as well. Now let's go Shift-A and add yet another cube companion to help us clear the garbage on the other side of the mesh. Position it like this. Control- for the Boolean operation. And by the way, yet another method of collapsing the modifier stack is to right-click on the mesh, convert to and select mesh. And that action will apply all the modifiers automatically, and it is fairly useful, especially when there is more than one modifier in the stack, so it becomes quite a faster option. My general workflow here is just using cubes to clean up the mess. It's a fairly simple yet elegant solution in many cases, especially when the model allows for it, when it is sufficiently simple, let's say. Alright, it seems to me that we have almost cleared the ground. And by the way, by using the Boolean modifiers, we don't close the door to just fixing things in the edit mode. We can still select vertices and make sure you're not in the X-ray mode if you don't want to project the selection all the way through. What I want to say, I think, is that we can still fine-tune things manually when it makes sense, when it's faster or more intuitive. Or maybe the shape of the Boolean object needs to be somewhat more complicated than the cube allows right out of the box, no pun intended. Like here, you can see me cleaning some stuff by selecting polygons or individual vertices and edges and just deleting it. The good old standard modeling operations, like selecting the edge loops by double-clicking on them and pressing F to mend the holes. And then we can still move back to using some more Boolean operations at any point of the workflow, because these things are not mutually exclusive, these methods. We can still use the Boolean operation and then clean up the mess by stretching vertices around. That's completely viable, mixing these workflows together. What else do we have to do? I think I feel slightly offended by the brownish Resident Evil slime below the car. I'm gonna wipe it out with Booleans. Control- after selecting both meshes. And I'm gonna adjust this face. We can switch between vertices, edges and faces selection by pressing 1, 2, 3 on the keyboard, by the way. Then right-click, convert to mesh. And I think it brought us pretty close to the completion of the first portion of our cleanup. I hope you like our logical geometric operations as a cleanup method. It's such a nerdery, I think. As for the relatively low poly mass below the truck, I think it can be enhanced with the use of some extra objects. I'm gonna start with a plane. From all good things starts with a plane or a cube in Blender, you know. We will need just one vertex, so let's select this one, Ctrl I to invert this selection and delete the rest of the vertices. G to move this one into place. What we'll do in a second is reconstruct this wire with the help of the skin modifier, but we need some kind of an edge structure for it to work. So I have extruded a bunch of vertices with the use of the E shortcut. Let's have a peek at how it looks in the solid shading mode. Not very enticing, right? Let's add the skin modifier now. To be able to adjust the thickness of the modifier, we need to select all vertices. We can do it simply by drawing the rectangular selection around all these vertices in the X-ray mode, then Ctrl A and adjust the thickness of the skin modifier in this way. I will enable the smooth shading as well. And when dealing with the low poly game-like assets like this one, we can take this concept of adding extra details on top of the low poly mesh as far as we want, really. Just a few seemingly insignificant details like hanging wires can alter this silhouette and make it look much more detailed. After all, when we are in the territory of low poly shenanigans, stuff like that is our smoke and mirrors. We can really make it look more detailed than it actually is. Along the same lines, I will select a bunch of polygons, press E for extrude and Alt S to push it outwards, just to break up the shape of this thing a little bit. Then I'm gonna Shift D to duplicate this object. I think it would be cool to add some kind of cable over there. This is the place where the silhouette can be broken up for extra detalization, so we can use this opportunity. With all vertices selected, I'm pressing Ctrl A to adjust the thickness of the skin modifier once more. And I think we can duplicate these two wires to the other side as well. There's probably no need to waste time cleaning up the space for this stuff. We can just slap it on top and it will work. That's probably not the cleanest approach ever to game assets, but keeping in mind that this asset probably won't be used in a close-up range or something like that, I think it will work, it will suffice. Here I'm adding yet another extra, which is cylinder with just a few vertices. Let's say 8 vertices, and it will serve as a replacement for this detail underneath the van. We can extrude some faces and generally have fun with the shape. I for inset, E for extrude, to break up the silhouette once more, and shade smooth. It may not sound like a big deal, but if it allows us to break up the silhouette in some interesting way, or maybe if it helps us to cover the most vicious low poly parts that draw the attention otherwise, it is totally worth it. And the other parts of the car that need our attention are the wheels, I think. I think we can play it safe from the standpoint of accidentally seeing the inside of the model from certain angles and just replace, or rather complement the wheels by inserting cylinders inside them. So I'm roughly positioning this newly added cylinder to encompass the wheel, or to be placed inside the wheel rather. I'm gently pushing this face inwards so it hides inside the wheel like this. And now let's work on the connection of these two objects. Basically, it's the matter of selecting a few edges like this and roughly aligning them to the shape of the wheel. So it kind of creates the solid object, which is obviously not the case here, but it will look like this. This vertices stretching operation may seem a little bit tedious, and in fact it is tedious, and it may take some time to just make it look like it's the solid object. And at the same time, to hide all the intersections. Actually, we can delete this face. We just don't need it, I think. One thing worth mentioning is that there's no need to be extra precise with such filler geometry. It can be a really rough geometry indeed, just blocking out the shape. The whole purpose of such filler geometry is to just hide the back faces so we don't accidentally see through it from some crazy camera angles. So here is the second blocker, and I'm doing the same things as with the first one. Grabbing some vertices and lining them up with the shape of the wheel like this. If there's a little bit of self-intersection going on, it doesn't matter much. It will be totally hidden once the textures are baked, so no need to care about that too much. And here goes the third wheel, and the fourth one, I believe, is already a manifold object. Cool, so that's our little detailing pass that we didn't know we needed, but the main point of this section, I think, is that we can still add details to this model even without retopologizing the source itself. Now making our way to the windows. It is probably the most challenging part of the whole thing, but let's try to do it. I will switch over to the orthographic mode. You can press 5 on the numpad to switch between perspective and orthographic, and I will do a quick vignette or outline for the window shape using this vertex of our newly added plane. Ctrl I to invert the selection, X and delete vertices, and that will leave us only with that vertex. We won't be using snapping in this case because we have switched over to the orthographic mode. It means that we can work in this projection without any perspective, distortion and depth cues. So by pressing E for extrusion, I'm slowly and carefully outlining the inner frame of the window like this. There's an odd zen in this activity of extruding the vertices, you know. Retopology can be hypnotizing. So I'm finishing this window frame. F to join the last two vertices, A to select everything, every vertex. And in just a second, this object will become our outline that will bake into the geometry of the car. I'll call it project. What I will do next is left click on the car_proxy model, tab to get into the edit mode, control click on the project_01 in the outliner, then we can either hit space and search for knife project, or go into the mesh tab and find it there. What this operation will do is imprint the edges that we have just created onto the car geometry using the orthographic mode we are in, and it will create a pretty clean and nice edge of the window frame, and so we can select the inner faces like this and delete it if we want, or separate it, for example. And that's precisely what I'm going to do by pressing right click, separate, selection. And as you can see, as a bonus, we've got this nice extra object with a clean edge, which is really important. To take it a step further and make it a touch more interesting, I will push it slightly inwards like that to create a parallax. It's more convenient to do that when the origin is set to the object geometry like this. That can be done in the right-click menu. And so we've got a nice little depth going on here. Now we just need to recreate the glass, and we can use the same object that we used for projection. I'm gonna tab into the edit mode, select all vertices by pressing the A shortcut, and then simply press F to draw the face. As the vertices lie on the same plane, because they were created in the orthographic mode, the resulting face will be perfectly flat. That's good news for everyone who fears n-gons, I guess. Once again, it's not very convenient to move things with a messed up origin, so right-click, set origin, origin to geometry, then R to rotate, G to move. There is some minor self-intersection going on, but I think it can be avoided by submerging this glass object a little bit deeper. I think it looks passable, even good, so we can move on to other windows. Alright, for this window I'll use pretty much the same technique, with a slight twist. Let's start off by pressing 5 on the numpad to get into the orthographic mode. Sometimes you may find that you have to press it a few times if you were in the orthographic mode to begin with. Anyways, let's get this starting vertex. In the orthographic mode, use E for extrusion to draw this shape that roughly corresponds to the outline of the window. If the resolution doesn't allow us to clearly see the outline, we can just imagine it. No big deal. The last 2 points can be connected by pressing the F key. And then we are ready to fill in the face. With all vertices selected, F again. Sometimes it makes it easier to move into place by switching to the custom transform orientation from this menu. We need to hit plus to create a custom transform orientation based on the thing that is selected in the edit mode. Currently it's this face. And it makes it easier to move this object along the axis of the orthographic view we were using for drawing it. So it's quite convenient. Then we can add the solidify modifier to create the object that can be used for Boolean operations. So that's the extra that I promised. We can use the Boolean operations to carve out the shape of the window and then insert the glass. So I'm duplicating this object because I forgot to do it in the first place. We still need our glass mesh, I think. So click, shift click, control minus on the numpad for the Boolean difference operation. We can grab this cutout object by pressing G key and move it around. And I think it works pretty good. I'm not sure that it's worth it in this case, to be honest, but it's working. At least it creates a nice clean opening and somewhat redraws the topology in this area. And then we can cover it up with a window like this and call it a day. That being said, I'm not sure we'd need this Boolean object in the first place there. Probably the most straightforward way in this particular case would be to just edit the mesh by hand. So I'm gonna remove the Boolean object, position the window so it minimizes the amount of self-intersections with the car mesh, and then with the car selected we can jump into the edit mode and just move the vertices around so they no longer intersect with the window geometry. So something like that. Each technique has its own place, I guess. That's where things got a little bit philosophical. Okay, what can we do with this window? It is slightly more complicated, I think, because the shape is a little bit wavy and we need to accommodate for the shape changes for the undulations, so to speak. I will enable snapping to do that and switch the mode to face. That should do the trick. Now it doesn't matter whether we are in the perspective or orthographic mode. We'll see this orange circle drawn around the dot. That means that the snapping has been activated, and now after each extrusion the vertex will get automatically placed onto the underlying geometry. And it's extremely convenient when we want to rotate the flow of the geometry like this, for example, and just follow some crazy shape. That's the most basic retopology we can do. Still, it gets the job done, I think. And after we have this shape, we can fill it in with the help of the Alt-F shortcut. But first, let me tweak the vertices a little bit. A to select every vertex, Alt-F for the beauty fill. That's an odd name for the function. Okay, let's not forget to smooth the objects out. And of course, we need to do something with the protruding parts. The parts of the track model that are sticking out of the surface now. The snapping can be disabled, I think. And now we can simply select vertices or packs of vertices and move them in such way so they got covered by the glass. By the object that represents glass, rather. Alright, so that was the right side of the truck finished. We still need to do the central window and the left side. If you feel like organizing the scene a little bit, we can rename the freshly added object. Window. And now I will tackle the front window. Let's add a plane. Leave just one vertex, like this. Enable the face snapping. And that's our basic retopology setup, as seen in other parts of the course as well. E for extrusion, then left click to apply. Make sure that the snapping icon is still highlighted. And by the way, the shortcut that toggles snapping on and off is Shift Tab, if you want to do it a little bit faster. Okay, the bottom portion of the window is a little bit tricky, because the reconstruction was far from perfect there. Hopefully it will work though. Here we need to close the shape by pressing the F and while selecting two vertices at the end. And we pretty much got the shape that can be filled with polygons. It will probably be far from ideal, but let's try. Alt-F will create this fan of triangles. Alternatively, we can press F without Alt for an n-gon like this. And under the hood it still uses triangles and it will get exported as triangles, but at least it looks a little bit more clear in Blender. So let's go with n-gons. If we had to move this object around, it could be useful to go into the Transform Orientations menu, delete the previous custom transform and create a new one, but we won't be moving this stuff around too much, I think. So what I did is duplicated the object, Then we can add the solidify modifier and add a little bit of thickness. This will become our Boolean cutout object in just a moment. So after generating some thickness with the solidify modifier, I'm pushing it inwards, then shift clicking on the car, Control minus to add the Boolean subtract operation. And if you didn't forget to duplicate the object before turning it into Boolean cutout, you should have the window available. It's fairly tricky to tweak the thickness with the bounding box mode set on in the viewport display settings. If that's the case, we can change it to wire. It's a much better representation of the actual 3D form of the Boolean cutout. So that's the life hack. So here we go. What we did is freed up and cleared up the window space by utilizing the Boolean subtract operation, and then we inserted the glass over there. Finally, we can apply it Boolean and pretend that it was like that from the start. Well, the resulting geometry is pretty ugly, but we will hide it. We will hide it somehow. Maybe by using some clever shading. That's what everybody do, I heard. Okay, what else do we have to do? These windows, I think. For a change, let's try a little bit different technique this time. For the left one, even though we start with the plane, we'll end with the plane as well. Sometimes we can get away with just using the plane, I guess. The only modeling operation I'll do is select these vertices and press Ctrl-Shift-B to bevel them, adjust the segments with the mouse wheel, then move it into place. But how do we fix the intersections? This time let's jump into the sculpt mode, and with the help of the default brush and holding Ctrl to reverse the effect of this brush, we can gently recess the areas that are protruding through the glass object. Like this. Just don't forget to hold Ctrl or click on the minus icon to switch the direction of the brush. Alright, now back into the object mode. We can copy these two windows, I believe, by pressing Shift-D, then Ctrl-M for mirroring, and mirror it on the X-axis. So Ctrl-M and X. Something like that. It fits right away, proving that the car was symmetrical. Surprise! We still need to fix it, and we can do it again with the help of the sculpt mode. With the default brush, reversing the direction by clicking on the minus, or just hold Ctrl, and that reverts the effect of every brush, and then gently massage the polygons that cause ugly intersections. It shouldn't be too hard to do that. Actually, I think that the sculpt mode in Blender is oddly pleasurable. Alright, I think we can do this window from scratch. So I'm gonna create the plane, delete everything but this vertex, and use good old snapping and retopology. It has a somewhat tricky shape, so that's, I think, the easiest way out of this situation. E for extrude, F to connect two vertices, and then simply select everything with the help of the A shortcut and press F to create a face. And once more, down into the into the sculpt mode, gently recess the parts that were protruding. That was our cleanup routine that involves sculpting for a change. I hope you liked it. Sometimes we may notice that the certain areas of the model are way beyond repair, like this section. I think it's a little bit too much, a little bit too wavy. And in the cases like that, what we can do is actually reconstruct these parts of the model from scratch, just by adding some extra geometry on top of it. It can even be like a decal, a floating geometry, a floater, that we simply add on top, not caring about the topology and stuff like that, just as a quick fix. Like you see here, we just placed a bunch of quick edges and vertices, then F to draw the face, like this, and J to connect these two vertices, and this geometry pretty much serves as a patch that is meant to hide what is underneath. We can assign a different material to it, like this reddish one, to signify that it's a patch. Oops, don't forget to disable the snapping when doing geometrical operations with it. And then we can sweep the geometric trash under this rug. Just like that, and maybe add some extra thickness to it. It can be done with the help of the solidify modifier or just extruding all the faces outwards. So here we go. We can work like that with applying quick fixes and patches. Alright folks, what else do we need to do? Maybe we should extract the headlights. That can also be done with the help of basic retopology. Something like that. Then A to select every vertex and F to fill the geometry with a face. Then right click and shade it smooth. Okay, now onto the mesh fixing party. Jump into the sculpt mode and push these polygons away from view. So they submerged beneath the newly added headlight geometry like that. And the second one can be just mirrored. So Shift D to duplicate. Then we need to set the origin to geometry from the right click menu. Then hit Tab to enter the edit mode, Ctrl M and Y to mirror on the Y axis. That should do the trick if we did everything right. And then I'm just pressing G and moving it into position. R to rotate. The intersections still need to be sculpted away. And it looks to me like we have completed all the glassy parts. Before getting to the roof part, which is really weird, I want to show one more technique of interacting with low poly geometry like that. It's called the knife tool. It allows us to cut the geometry the way we like it, even if it goes against the flow of existing topology. We can still press K and then cut it like this, for example. It's as close to the freeform topology drawing as it gets, and sometimes we need to slide vertices by pressing G twice. So G for sliding it up. It corrects the UV map automatically, so when you slide the vertex, it doesn't stretch the UV map, which is nice. Then we can activate the knife tool once again by pressing K, draw a couple of edges, and then release the left mouse button. G to slide the vertices. And in this way we can define the new geometry on top of the existing one, and that is extremely useful without any doubt, especially when the source geometry is far from perfect. In this sense, it's a little bit similar by intention to utilizing Boolean operations to create this sort of new outlines, new shapes, new forms inside the existing forms. So it's good to know that we have this free form alternative to Booleans. And with these new smooth edges that we have drawn, we can switch over to the face selection mode, then press C for the brush selection and select all the inside polygons like that. And then press, I don't know, press P for separate or X for delete. That is super useful for separating the parts of existing geometry and creating modules for that matter. And then we can, for example, jump back into the edit mode and keep adjusting the topology. So what if we draw the rectangle over there and then recess this part to create a new detalization in this place? I think the extra detalization like this, sprinkled across the relatively low poly base, will help us to sell the illusion of, you know, higher definition thing than it actually is. By the way, I'm extruding this set of polygons inwards, so it creates a nice parallax effect. And I think it works really well, all thanks to the knife tool. Probably the most glaring error of our mesh reconstruction due to missing camera angles is the roof. So before taking it back to reality capture in order to bake textures, we need to do something with it. At the very least, we need to rebuild the flat surface there. So from the top orthographic view, I'm creating the plane object. And I'm gonna use this vertex to retopologize it really quickly. No need to enable snapping because we're in the ortho mode. E for extrude. We have done it a couple of times already. That won't be a sophisticated reconstruction, just a patch of polygons that we place on top of this thing to cover it. I think we even don't have to delete the wavy polygons in the first place, just cover up this mess. So G and Z to move it down, and then I'll extrude this face like that. Well, thinking about it now, we could have made a hole first with the use of the Boolean modifier, so we don't have to sculpt anything, we just can place our patch and be happy. But anyway, sculpting doesn't take long, especially if the only thing we really want to do is just hide the mess. So it becomes a fairly quick process. And we pretty much did it in just a few clicks. The rest is fine-tuning the edge, either in the sculpt mode or just by moving vertices. And I suppose this will do the trick, especially after rebaking. It will look more integrated, I believe. Alright, I realized that we forgot to make the rear window, so that's what I'm doing here really quickly. The same set of tools activated. And it looks to me like we have finished tweaking our proxy model, and we have effectively turned it into a fully fledged low poly model with the help of these extra assets. The rest will boil down to temporarily joining these parts together, so it's effectively one object. And moving these objects to reality capture for baking all textures, including diffuse textures, normal maps, so on and so forth. Probably we won't need anything outside diffuse and normal. It already looks a little bit less grainy and less cursed, I guess. Our next step, I guess, will be to help the high poly version of the car be the better version of itself. So feel free to make a short break, prepare yourself a cup of tea or coffee, and let's keep rolling. So we've prepared the low poly version of a car that looks passable. Now we need to share our love with the high poly version to make it less grainy and basically to prepare it for baking. We need to switch over to the HP collection that contains the high poly version. As we remember, it's quite noisy. There is quite a bit of grain in there because we didn't do any kind of smoothing in reality capture, and for a reason, because we wanted to do it by hand. The manual method seems to be slightly more customizable, let's say. But first, before sculpting it out, I'm gonna duplicate this mesh and put it into its own collection. Let's call it HP_sculpt and drag the duplicate over there. We are going to spend some time in sculpting mode, so it's handy if you have a tablet, but if not, don't worry, it's fine. The solid shading mode is slightly faster for sculpting, so let's use it. And as for previewing the vertex colors, I'm not really sure about it. Probably let's stick to the solid material, with or without the specular lighting. It's up to you. Throughout this denoising session, I will use just one brush, which is the flatten brush. It works kind of similar to the smooth brush, but it's slightly less radical, so to speak. Again, if you have a tablet, it makes things easier, but it's completely possible to do it with mouse. It's one of these brushes that are not super demanding to whether it's mouse or tablet, I think. What we are doing here is gently laying out the strokes across the main curves of the surface, just like when, I don't know, doing makeup. For some reason this analogy comes to mind. When you do makeup, you lay the strokes alongside the main curves of the face. So in other words, the direction matters. Sometimes you may discover that you want to zoom in slightly closer to tackle the higher frequency details, and that's fine. Like this surface. You kind of control these things by zooming in and adjusting the size of your stroke in relationship to the size of the surface you are adjusting at the moment. There could be some complicated bits, like this mirror, and sometimes you may want to rebuild it from scratch rather than adjust it like this in sculpting, but I think we can do it, even though it looks like it's made of jelly right now. Maybe you can use the scrape brush to introduce some harder edges in there. The scrape brush is one of these signature hard surface brushes, and so it's useful if you want to introduce a bunch of harder edges and just engineered shapes, I guess. And probably no need to be super pedantic about it. This is still the model that is supposed to be the background asset, rather. Okay, switching back to the flatten brush to keep working on denoising this model. Even though polishing the model like that is not a super complicated process, it doesn't look like that, definitely, it still could take some time. So prepare yourself for at least 15 to 20 minutes of sculpting zen. I usually love listening to some music while I'm doing that, especially my favorite ambient soundtracks from games, from Minecraft, from Summer Roast. This type of non-super distracting but still thought-provoking and emotion-provoking music, it really helps me to snap into the zone where I can enjoy such meditative processes like sculpting, you know. I wonder, do you listen to music while working? Hit us up with the answer on Twitter if you wish. Alright, so as we have mentioned, we zoom in from time to time to tackle these smaller details, and we are trying to align our brush strokes to the forms of the surface. Like this is evident in case of this wheel. Like we are using the circular strokes kind of. I guess it just helps to maintain the overall flow of this thing dictated by the big shapes which we're trying to align to. And to keep my perception fresh, I'm constantly jumping back and forth between different parts of the model to not overdo certain parts, and generally to not spend too much time polishing one small section. It's easy to get lost in this process. So it's important to constantly switch the areas of attention. It's interesting that even though we try to polish the noisy parts out, we still leave some noise in the crevices, and just it gets scattered in this kind of an interesting non-uniform way, I would say. It definitely doesn't feel the same as blasting the whole thing out with some smoothing filter. It's a completely different vibe when you do it by hand, when you naturally do it in a kind of a non-uniform way, which shows through, which really does, I think. I think that the small pockets of high-frequency grain left here and there due to non-uniform strokes will have a potential of making the normal map look more detailed. The non-uniform distribution and the clumps of detail in certain places go a long way. Alright, I think the flatten brush helped us out to polish this thing to a certain condition. It no longer looks to me like it's made of foam. And from here we can safely take it to reality capture and use it as the high poly model to bake the normal map from, I think. Well, maybe it still looks a little bit lumpy, but that shouldn't prevent us from extracting a normal map. Switching back to object mode. Just giving it a quick inspection from all sides. Yeah, it's really better this way. I wonder if you agree. Actually, you can compare the before and after by switching back and forth between HP and HP_sculpt collections. Alright, awesome. That makes us ready for the next part, which will be baking textures in reality capture. First of all, as a precaution, we need to right-click and shade it smooth. Then File, Export, and choose the OBJ format for exporting this model out. Then a new folder for it, of course. 03 for baking. Everything should be named descriptively. Everything. Then in the Transform tab, forward should be set to -X, and up should be Z for reality capture. Everything else at its default values. It may take a while to export this model, it's pretty heavy after all. And what we need to do next is enable the visibility of the proxy model, which we have just tweaked. And as for the moment, it consists of a bunch of objects which have to be joined. But first, I will probably create the new collection, or rather duplicate this one, so we don't accidentally mess it up. I will call it for export. And what I'm going to do next is select everything, every piece that composes the proxy mesh, and then right-click and join. Disclaimer, here I made a mistake. We should have applied the modifiers first, because after joining it like this, some modifiers have been reset. For example, the skin modifier, it has turned into a pumpkin or into a spline. Fortunately, that mistake won't influence the final look too much, but that's something to keep in mind. First the modifiers have to be applied, then we join things. Alright, right-click, shade smooth. Then a couple of preparations that we need to do before exporting it. First of all, let's make sure that there is only one UV map and that the model has been unwrapped as well. So I'm selecting all polygons in the edit mode, U, Smart UV Project. And okay, we don't care too much about the quality of the UV map, we just need that UV map to be available on importing. And then I'll delete the vertex colors set, because that trips reality capture up for some reason when the model has the vertex colors. The last check that I'm gonna do is the face orientation check. The faces marked in red are flipped, so I'm pressing L while hovering over this element to select it. And then I'm searching for flip command in the Blender search bar. L again to select all linked faces, and flip. L again, search, flip. And here we have one more. And then all faces are shown in blue, meaning that no polygons face the opposite direction. We can export it out. I think we did everything to make sure that there are no errors in reality capture. We should be good to go, really. I'm searching for export obj command, just for a change, not to do it from the file menu, but in this way. And I already have exported something, so I'm just exporting on top. The triangulate faces checkbox should be turned on, because otherwise reality capture will have problems with n-gons. Actually, a lot of software has this problem of interpreting n-gons, so it's worth triangulating the faces before exporting it out more often than not. That's something to keep in mind. Now launching reality capture to load all these meshes up that we prepared in Blender and start baking textures, specifically the normal map. Click on import model in the mesh model tab. Let's get the low poly first. Ignore the prompt that tells you that it's strongly recommended to clean the model to remove topological defects. Just say no to it. Otherwise, RC will try to fix the model by making it manifold and it will explode. Okay, the black texture is alright. That's how it looks by default. We just need to unwrap the mesh again. The RC unwrapping algorithms are slightly better than the current state of affairs in Blender, so let's do it. But first I will set the resolution to 2K in the unwrap settings. The large triangle removal threshold should be set to 100 to make sure that absolutely all polygons are unwrapped. Otherwise the bigger and stretchier polygons will get excluded from UV mapping. Okay, then in the texture settings, let's check the downscale parameter. It should be set to 1. We definitely don't want any kind of downscaling applied to our source images before texturing. And then just click texture. That is not necessarily baking of the diffuse texture. We generated a new one. We will need baking to derive a normal map though, in just a moment. A quick inspection, and I can tell that it looks awesome, I think. Sometimes photogrammetry amazes me, because we have used a smartphone in order to capture the source photos, and we got such a nice model. It's crazy. I will rename it to car_low poly or LP. And what we can do next is come over to the texture reprojection menu. Choose the source model, which should be our sculpted version of the high poly. That's important. And the result model, which is the LP one. Then turn on the normal reprojection and disable everything else and hit reproject. Now we are baking the geometrical intricacies from the high poly model to the low poly one using normal map as a container for these sort of details. And it looks like this in reality capture, which shows it in the world space, I guess. It will look properly like a standard tangent space normal map once exported out. It's just this interesting kind of preview. And so we got the diffuse texture and the normal map. And that's all we need. That's the process of rebaking textures in reality capture. Of course, if you don't want to use RC for doing that, you can use any kind of baking software like XNormal or even Blender or pretty much anything else that can bake stuff. Finally, I'm exporting the car_LP model into its own folder called baked. And that pretty much concludes the baking workflow. So save. Let's have a look at the settings. As for the texture side, I think 2K pixels wide for the entire UV map is more than enough for this model, especially considering that we will be upscaling it in just a moment using neural networks. That will be exciting. Keep watching. Alright, creative shrimps, let's finish it off. Back to Blender. We will need one more collection. That will be the final one for today, I think. Let's call it baked. And then go File and choose FBX. That's the intermediary format we used for exporting this stuff out of RC. And from Blender to RC we used the OBJ format, as you remember. The easiest way to check if the textures got imported is to toggle on the material preview mode. and it looks like they were imported indeed. But what if not? What if not? In order to have a look at the shader and the textures for that matter, I will open the shader editor in the top window, which we have just expanded. So, by looking at the material, we can tell that there's the diffuse map. It goes right into the base color input of the principled BSDF shader, and that's how it should go. And here, scrolling down a bit, actually let's drag it up. Here we have the normal map with the non-color linear space, and the normal map naturally goes into the normal input of the shader. Normal mapping magically fakes the bumps and dents in the model that aren't physically there, and even though our normal map isn't of highest possible quality, it will do its job in faking this extra detalization that isn't there. As we have already mentioned, it probably won't hold up for the close-up shots, but for the background and mid-ground assets it will provide that extra oomph. Alright, what I'm going to do next is tab into the edit mode, choose face selection, and then on hovering over these windows I'm pressing L to select linked. And this basically selects this element that you're hovering over, if it's not connected to the rest of the geometry like these windows. Right click, separate selection. And so it got detached. Now it's easy to hide that by pressing the H shortcut, for example, assign a different material to it, so on and so forth. I will also separate this thing, whatever it is, a curtain, I don't know, P, separate selection. And now Alt-H to unhide everything. The windows should have a different material, obviously more glassy one, so back into the material settings I'm pressing this icon, renaming the resulting new material to glass, and then we need to adjust a few properties of the principled BSDF shader to make it look like glass. First of all, alpha, or transparency. To make it work, we need to go down to the material settings in the right tab and change the blend mode to alpha blend. And also check the backface culling to remove the bug related to multiple refractions. And now the alpha slider should make it more or less transparent. What other properties make it look like glass? It should be pretty glossy, or less rough, let's say. And then I don't think we need to adjust the specular level. We can test how it looks, how it catches reflections by rotating the world panorama in the viewport shading tab. Pretty awesome. Our low poly car asset is really coming together and is really reminiscent of the stuff you might see in games in terms of quality. And you may even check the interior. How awesome is that? It may come in handy at some point. So, to finish it off, I will add the color ramp and connect the diffuse texture to it, and then connect it to the roughness input of the material. What I usually do is reverse the flags like that. But for the sake of love, be careful to not make it overly glossy, because glossiness is something that reveals that the model isn't super high quality. Potentially it can dissolve the illusion. We don't want it. So if you can, just keep it diffuse as possible, at least in the case of such meshes that weren't produced in the ideal conditions. Glossiness is dangerous. Whoops, it seems that I forgot to detach the headlights. Let's do it now. L on hovering, P and separate selection. We can reuse the glass material for it. So down in the materials tab, let's click on this icon and select glass. We have named the material and now we can find it. So what we did is detach the headlights and the windows, made it look like it's made of glass. Now we just need to tackle one last thing, which is this god-awful roof. This will be the last thing on our list that needs to be fixed, and then we'll try some neural network-based upscaling of textures. That will be exciting. Before passing the textures onto the neural network-based upscaler, we need to fix the diffuse texture specifically. Perhaps the easiest way to do it would be to come over to the texture paint mode and use our good old clone stamp tool. Shift right click places the 3D cursor or the sample area for the clone stamp tool, and then we can brush away. Shift right click and then clone stamp it. It is worth pointing out that currently the clone stamp tool in Blender works in the screen space mode. So if you'd like to clone from the surface that is turned away from the camera, the easiest way would be to get into the edit mode, Shift D to duplicate the mesh one more time, R to rotate. It is fairly awkward to do it like this, but that gets the job done. So you just rotate the duplicate of the mesh in what orientation is needed currently, and then place the 3D cursor with the help of the Shift and right click and do the cloning from that region, from that area. I thought that the door material looks fairly similar to what we expect to see on the roof, so I'm cloning it from there. And once we've finished, we can delete these unnecessary duplicate. So back to the edit mode, X, and deleting all vertices. A confession, I made a mistake here. I forgot to save the diffuse texture that has to be saved after we did the clone stamp work on it. Alright, anyway, I think we can adjust the alpha for the windows furthermore. I'm not really satisfied with the amount of the interior we see through it, so I'm reducing the transparency gently. What else do we need to do? Maybe reduce the strength of the normal map for the window material as well. It looked a bit too aggressive, a bit too warped. And lastly, I think we can try to fine-tune the lightness of the diffuse texture to make it look like it's slightly more dusted. I'm pushing up the RGB curve a little bit, so it makes it look, I wouldn't say frosted, but maybe something along these lines, covered with diffuse material of some kind. Well, actually, I think it already looks pretty good for the asset that isn't supposed to be the hero asset in the scene. It isn't supposed to be viewed from the close-up range. It has some sort of a PBR material that we have just set up. And even though it has started from the fairly low quality sources and went through this kind of hacky pipeline, the end result I think is good enough, at least. To be fair, at this stage I think it don't need much more tweaking, for sure. It already works quite good. Maybe, just maybe, I will reduce the specular component of the BSDF shader a little bit. It may help us to hide the flaws furthermore and make it look even more old. And what I usually like to do is test the model under different lighting conditions to see how the PBR shader interacts with the light and how the whole thing holds up. And I think it holds up nicely, just nicely. The textures aren't supposed to be super clear for this kind of model, but we can try to improve it. We can still try to squeeze as much juicy quality as possible out of this thing. Let's do one more thing, which is upscaling the textures using neural network-based solution to see how it helps us to take it to the next level or not. This is exciting. At first it may seem a crazy idea to try to artificially bump the resolution of our 2K baked diffuse texture, but it's not as crazy as it seems. Our source material wasn't super great to begin with, and baked textures ended up being a little bit blurry, so there's a potential for upscaling it. I'm using the Cupscale image resizing tool that can be downloaded for free from GitHub. I'm leaving the link on the screen. And after you download the tool, the first thing that has to be done is installing the dependencies. If you don't want to download the Python distributive manually, the easiest way out of this situation would be to go to the Resource Files tab within the Cupscale settings and click on Install Dependencies. You can see that I have done it already. And after that, hopefully, if we did everything right, it should work. The process of upscaling is actually super straightforward. We need to drag and drop the diffuse texture in this central window. So far it hasn't been upscaled. This is our original diffuse texture. As a quick reminder, it has the resolution of 2K by 2K pixels. We can zoom in to see those pixels in their full glory. And now it's just a matter of selecting the AI network to run. I'm picking Real ESR GAN. Next, down in the model settings, I'm choosing the model which is Real ESR GAN X4+, meaning it will upscale the image by the factor of 4. And that's pretty much it. That's the setup. Now we can click Refresh Preview and let the tool do its AI resizing job. We can track the progress at the bottom of the screen, and it goes from 0 to 1, not from 0 to 100. That's a little fun thing, I guess. And so it took approximately 40 seconds to generate this higher quality version of image. And honestly, I think it is ridiculous. Look how it has resized everything with retaining or even enhancing or daydreaming the edges and small details. It is mind-blowing. It should be so good because our perception of sharpness, I think, largely depends on the edge detection. So daydreaming the edges like that should really help with the overall clarity, perceived clarity of the texture. And we don't have to use the 8K full resolution one after we generate it. We can downscale it back to 2K texture with retaining a little bit of sharpness. That's not something that I'll do for this tutorial though. We will use the full resolution 8K resized texture, just to be clear. Alright, to save the texture we should click the Save Current Merged Preview, and the new PNG file will appear nearby the original one. It will have a suffix added to it, that's how we can recognize it. And essentially it will be the 8K texture instead of 2K. Now for a quick comparison, allow me to expand the Materials tab and just swap the texture to the new one and then go back and forth to compare. So I'm gonna click Open within the Image Texture node representing the diffuse texture, then select our newly generated thing, which is 8K, and whoa! Look at that! I'm gonna press Ctrl Z and Ctrl Shift Z to show before and after. And that is quite impressive. It doesn't make this asset a close-up one by any stretch of imagination, but I think that boost in quality is quite impressive anyways. It adds that extra crispiness or zing that is usually associated with a higher quality or higher fidelity material. Alright folks, before wrapping this tutorial up, I want to fix a small blunder that makes me itch, because it really affects the final perception of this model. It may not seem like a big deal, but this roof that we have created is a little bit too straight. It has these kind of straight edges that really look like it's a low poly model from Counter-Strike version 1.6 or something like that. This stuff like that becomes especially evident when viewed in the flat shading mode in the viewport. Just look at these pointy edges and straight lines. This is no good when it comes to trying to sell the illusion of the higher quality model. We'd better get rid of these edges. I think it's definitely worth reworking this part, even if it takes us a few extra minutes to do that. I think the final result will speak for itself. So what I'll do is select this part in the edit mode, hit X and delete all the faces to get rid of it. And now we should be clear for creating a new plane, extracting one vertex out of it like we usually do for retopology, and then enabling snapping from the top menu here. By default it's set to faces, like it should be, and then some extrusion has to be done. As a quick reminder, the shortcut for extrusion is E, and by doing it like that, instead of creating it in the orthographic mode, we will make sure that this newly added patch will actually conform to the shape of the roof. This resulting patch won't be flat if we do it like this, but what is flat in reality after all? I'm pressing Alt F to fill it with triangles, then E for extrusion, something like that, maybe extrude it a bit more. Then we need to do something with the pointy parts of the car protruding through this thing. Getting over to sculpting mode now with the draw brush selected, and now I'm holding Ctrl and gently pressing or pushing these parts of the mesh that have been protruding through this thing. I'm trying to be extremely careful with that to not accidentally cause this weird waviness to the underlying geometry. That won't be good. Okay, getting back to the object mode now. The next step would be to give this thing a UV map, so I'm opening the UV map editor. Then having these objects selected in the edit mode, I'm pressing U and selecting Smart UV Project. And it seems to me that I didn't select all the polygons, so let's try it again. Smart UV Project. Alright, now we need to find the placement for these newly created UV islands to basically fake the roof texture by borrowing the part of the existing one. To be able to evaluate it, the car material has to be assigned to this new object, so I'm copying it out from the car. It is such a fake method of doing it, even more fake than trying to clone the parts of the texture in the texture painting mode, but as long as it works, it works. All we need to do technically is try to find the right placement for the UV map. I suspect that we can borrow the UV map placement from this part of the door. It is essentially the same material. In the end, nobody will be able to tell that it's actually the same material if you place it in a broader context of a scene. I think we can get away with it. I'm really happy that we did it though, thank you for your patience. This minor blunder was causing me itch, and now it's gone. And that means that it's time for even more tweaks, right? But this time I won't bother you with it. Feel free to download the project files. I tweaked a few minor things here and there. But generally, this is it. That is our resulting model. I have restored the wires and made the windows slightly more glossy so you cannot see through as easily. A fairly insignificant change that still adds that extra visual pop that we crave so much. Just look how it reacts to the light. Yummy. Let's see how it looks under the different lighting conditions. Actually, I think it looks gorgeous. Especially for the photo scan captured in this kind of a lazy way on a regular smartphone. Honestly, I didn't expect to get to this level of quality, which isn't great by any means, but that is quite enough for the midground and background asset, and the production time was relatively fast, and it's really liberating, if you ask me, to be able to do photogrammetry like that while walking to the coffee shop. And then rebuilding it to this level of quality. That's impressive, I think. Personally, I want to spend just a few more minutes with this model, just playing with it, seeing how it looks in different contexts. I have added the ground plane that resembles this earthy material to see how the truck becomes grounded. No pun intended. I think it's just super fun to try to imagine how this model would look in the game-like context. I think it would hold up pretty well in a game engine.
Thank you for watching our crazy extreme smartphone photogrammetry tutorial. Hopefully you got something useful after all. I think we did a great job with processing not so optimal footages captured on a mobile phone. It is exciting what photogrammetry can do nowadays. If you want to learn more about reality capture and about prosumer workflows for photogrammetry, make sure to watch the full course. The links are in the description. Thank you for watching, drink more coffee, and we will change the world of computer graphics.